Hello, everybody. Phil Wightman, Laketec Communications. This is going to be part two of wireless and client troubleshooting in AOS8X mobility controller environments. And a lot of this, again, does translate over to AOS10 gateways. It just does not have the mobility conductor piece, nor the control plane. All right, so in the last video, we left off with looking at the show datapath command, and I had specifically show datapath session command, and I had specifically piped in the IP address of my client, and we're talking about these flags. Y flag means that the TCP handshake wasn't working, therefore concentrate on your uplinks out of the controller and anything through the infrastructure all the way up through the server and other firewalls in the environment. And then the deny flag, which we stated that means that the controller is dropping traffic based on the policies and the ACLs applied in a specific user role, because everything gets a user role. Oftentimes, you have policies here with ACLs that could be dropping traffic. So we covered on how to use that. So next up, sometimes we want to, we're the user, maybe we made some changes. Maybe we made a change in the radius server ClearPass where it's sending down a different role. Or we've adjusted the code channel. Maybe we've made some adjustments in the environment and we need the user to reconnect. So instead of having the user actually reconnect, because a lot of times if you just shut off the radio and reconnect again, the infrastructure has a grace period that says, oh, you just roamed. It doesn't really think that the user has literally disassociated and re-authenticated. It could deem that as a roam. Therefore, it doesn't force a full authentication. So we can force that, however, through the controller itself. So if we take a look at the user table again, because I want to grab the IP address of my iPhone as the test user, we know this is me here. The command to punt a user is AAA user delete and then IP address. And oftentimes I will either have them do nothing, or maybe I will have them shut off the wireless. I'll do this, which kick them off the controller. If we look at the user table, any good device is just going to reconnect immediately. It's just going to think it roamed, right? It's just going to lose signal and then hit another AP, or because I just punted it will obviously just reconnected to the same AP. So, but what that did is it refreshed the state of everything for all the information that the controller has learned about the client. So we could see all new stats. We could see a fresh authentication, which is especially important if we had made changes in the radius server and we're looking at the radius policy to determine whether or not it triggered correctly, so we can continue troubleshooting the problem. So yeah, so fresh connection there. So that's how you punt a user from layer 3 perspective. If the user did not have an IP address, maybe your change was you were changing, you were sending down a new role that was allowing DHCP. Maybe the other one wasn't for some goofy reason, but they only have a layer 2 entry on the controller. That command then would be in that, and as a reminder, that's when they're here in the station table, but not in the user table. So that command to kick layer 2 off would be this command here. So we have station manager, kick off station, and we need the MAC address of the user. And this command does there's an E there. In this command, I believe the BSS is next. Yeah, it requires what basic service set ID are they connected to. So we would do that there. That just kicked me off from layer 2 perspective, which should have also kicked me off from layer 3 perspective. Well, it didn't, just clears layer 2. But yeah, so that's how we kick them off if they didn't have a layer 3 session, which is good to know. Okay, so other handy commands. So because we just authenticated, we have what we call an auth trail. So an authentication trail. So we can show this command here, show user table MAC. The MAC of my client was this guy. Got that MAC address there, and then log. So this is showing, so this was a pre-shared key. It's not actually using 802.1x. So it's using pre-shared key. It's not talking to a radius server, but this is still good to take a look at, the station powered up. It did its four-way handshake for WPA. It went down here, probably because I kicked layer 3, so on and so forth. So this is a good log to look at to make sure that, maybe pre-shared keys not working. So we can run this command if they're not even connecting at all, like they're having troubles connecting. Maybe we should have started off with this one, but this is handy to look at. And then another relevant command along that same type of output, if I can remember, it's a show off trace buffer. So this is very similar, and usually we would grep this command, especially in busy environments. You saw even in my little environment that took a few seconds to run, but similar output here. This would show, here we are, we're failing free shared key, at least momentarily we're failing free shared key. We see later on that same client, if I were to grep that, did succeed. So I don't know what's up with that, but that could be something to troubleshoot if that was the reason why I'm digging into this stuff. But this would also show if ClearPass was unreachable, or I should say the radius server is unreachable, because the client or the controller obviously can't send authentications to an unreachable server. And dovetailing off of that, we do have this command called show AAA server group summary. So these are all the different miscellaneous lab radius servers I have set up. And if we saw, an unreachable here, we could take a look at this list to see, okay, well, that's unreachable. Are they all unreachable? So we could see what's been marked out of service. And they do naturally go back into service, but I believe the controller looks at clients that are not getting a response from authentication. Once it sees that, enough of that, I forget how many it needs to see, it'll mark it out of service, but then it naturally brings it back into service after a period of time to try again. I apologize about my my teams there. I should have that shut down. Okay, roaming. So maybe we're having roaming issues, or we just want to know where they're going back and forth between. Maybe they're bouncing back and forth between the same AP constantly. So we would look at, I believe, I don't know if I was 6443 there, but let's go get my guy, which was this guy here. So again, we look at the roaming via MAC address here, and there we are. So we can see today, over these periods of time, that I've been hitting these different, well, it's actually the same BSS ID over and over again, but some of it's because I've been kicking the client, and some of it is just because, the client is obviously, just reassociating to the AP or running through its association frames for some reason there. But some some good indication here. If you're troubleshooting roaming, this would be a really good command to use. Okay, so that's roaming trail here. A fun command. I don't know if it's necessarily really related to client troubleshooting in any great way. I guess it is related, but this show AP debug client state. Client stats for my MAC address. That's not my MAC address. For my MAC address, what was it here? My MAC address was this guy here. And then we want to, first of all, there's lots about, did I not have something corrected here? Client stats. Client MAC. Place that there. So lots of statistics here, drops, retry rates, all sorts of, transmit and receive information. But the fun command I kind of wanted to show you here is that you can look at the MCS rates. I don't want to type include twice. I want to type in MCS. So here we can see, what MCS rates they're hitting in most commonly. So it looks like, it has done data rate shifting down to MCS 7. And that's where MCS 6, even a little slower. This API I am connecting to is on the other side of a couple different walls. So I wouldn't expect to get, the highest modulation scheme out of here to get max throughput, because my client had the down rate shift in order to be able to discern the frames in the air. And it's down rate shift for the majority of the packets down to MCS 6. So fun to look at. Also gives you an idea of, how far down it's going, and because the lower it is here, it wouldn't be great that it's an MCS 1, because those would be the lowest data rates that the client could possibly use, which means you've got a lot of obstructions in the way, you don't have good SNR, interference, things like that. So that would be, if you see everything in here, that'd be something to look at as well. All right, next up would be we can actually run full debugs. So if we get out of the mobility controller context, now we're back into the mobility conductor context because I exited out of there. I'm already in the focus of the controller here. So any configuration changes that you do need to happen either via the UI or on the mobility conductor CLI here. So here, I'm going to go into configuration mode, and I am going to enable debugging for my user. So that command is this. So logging user debug. I think it's my MAC address here. Yep, my MAC address. And then I usually turn on all of the debugging. So level, because it's just one client. So I'll do all the debugging for that one client. But you can be specific. You can look at, say, just DHCP processes or DHCP categories, things like that. So I'm going to rate mem. So that now committed that to the controller. Now if I connect back to the controller with MD connect, or MDC for short, I'm now back in the focus of the controller, and I can look at the debugs, and you can see here now 839C is not enabled. There it is. Took a second to actually push that config. So 839C here, now debugging is enabled. So now I can do things like if I were to punt my client again, it's a fresh context, so I have to do it from scratch. Actually, I've got to figure out, I did not memorize what that IP was. This is me here. I'm going to kick my user, show triplet user, delete, bam. There we are, I've been kicked. Now I can do show log all. And there are lots of different logs you can look at, but I like to do all because I may not know exactly which log I want to look at here. But what I do want to do is I want to grep it by the MAC address, because anything that's logged into the log via debug is done by my MAC address. So I can parse this down. And show log all, I probably should have modified that command a little bit. So it's looking through all logs of the history of the controller since it's been purging or overwriting. That's interesting. What if my client didn't reconnect here? Let me see. So let's do that again. So I was, as I was starting to say there, show log all. Sometimes maybe I want to look at the last 50 lines in the log, or the last 100 lines, or I'll do the last 500 lines. And then I can include the MAC address, and we go here. It'll just speed up the command a little bit more. The controllers I'm using in my lab are very small, so they're not very fast. But again, they do everything that the big boys do. Just have to be a little bit more patient. And interestingly here, I'm not getting anything in the logging. I'm actually going to shut off my wireless. So I would have expected to see, authentication details there. 0477, it's here, 4047E. Is that what I actually ran the debug on? No, it's not. I grabbed the wrong MAC address. That's why we're not seeing anything. Okay, let's try that again. It's obviously not going to find anything with a Q at the end of my MAC address. Wait for that to time out. We're going to go back into the mobility conductor, rerun this command with the correct MAC address here. There we are. And then we're going to do level debug, write mem. And now we'll go back in MDC. And now I will user delete. My IP address was this guy. Myself, and now we can do show log all. We'll just do 50. Pipe include my MAC address. Sometimes I'll have a little notepad going so I don't have to keep on searching for that information. And it didn't grab it. Come on. There we go. Hopefully you have bigger controllers in your environment. This runs a little quicker. There we are. So now we have a bunch of information, and it was just a simple authentication here. So, we can see it's setting a role. It's done derivation. There was really no derivation, meaning nothing trumped to the anything that was in that role, such as the VLAN. Some basic information here. So I may have, and again, we could double grep this. Like maybe I want to look at the associations here, or dive into this for whatever it is we're looking for. Because I punted my user, I think it held on to its IP address. Normally we see DHCP information in here. And oftentimes when I'm troubleshooting DHCP, I literally just debug the entire DHCP process. Because even though we're looking at the debug for the client, it's not looking at, say, all legs of DHCP, the whole DORA. So I might have turned on DHCP debug initially so that we can see that, because this is just user debug. Yeah, so debugging can be your friend. Don't forget to shut off when you're done. You can see I never shut it off, but it's just the opposite of the command we ran a minute ago, minus the subcategory here. I believe we pull this off and we give it a no logging. And sometimes, like if I find that there's a bunch turned on, they're obviously not in use anymore, I'll take a minute to just clear them up here. Oh, and that was done, looks like from the cluster level. So can't do that one there, but maybe I can do this one because I know that was done here. So I could have been in the cluster level instead of directly on the controller when I created when I configured the debugging, and that would have applied it to both controllers. I was in the context of the controller I knew I was on, but yeah. Okay, so that's debugging. Let's go here. Let's go back into the controller. And we talked about the dead radius server here, which is a handy command. But we can also look at how radius servers are configured. Authenticate. So another handy command here to look at configurations of the radius servers. Here's all the radius servers I have configured. I can pipe one in specifically just to that would be radius CPPM1. And I can take a look at some of the details here. I can actually decrypt this. So there is a command we can run. It's called encrypt disable. So now anything that's asterisked out won't be asterisked out when I rerun that command. So I'm not going to do that here on this recording, but if I were to run that command again, we would see the passwords in clear text here, which is pretty cool. Okay, moving on. A couple of little things that isn't necessarily user or RF troubleshooting per se, but it's things that would be good to look at is just validate the cluster itself. So if, and I know this cluster, or this controller here is not clustered because I broke the cluster doing some testing a while back and I never recreated it, but I do have another cluster here. This is an AOS10 cluster. So again, a lot of the same commands we talked about earlier. This must not be mine. I have several clusters. Here, we can do maybe this guy. And I think this cluster is actually broke too because I was stealing the controller from it. But just to show you, even in AOS 10, we have a lot of similar commands. We still can see all of the datapath session because all this traffic is tunneled to the controller or to the gateway. They're called gateways when they're AOS 10 because they don't have the control plane functions enabled because Aruba Central is managing the APs in the cluster. So they don't manage APs directly. So now they're just gateways. They're tunnel termination points. So we can see all the same stuff here. But what I wanted to show you is this command called show LC cluster group membership. And here we can see it's only a single controller because I stole the other controller for some testing. But this one I think I left intact. So we can do show LC cluster group membership. And now we see a true cluster. So we have two controllers in this cluster. We could actually type in the name of that cluster if we wanted. No, we can't. Show LC cluster group. That guy, which really didn't give us any more commands here. What I want to get at here is this connection type. On AOS8 clusters, we will always want to see this as L2 connected. That means that for every VLAN that is configured on the controller, that the other controller also has those VLANs because it runs heartbeats across them. So when if one of the VLANs isn't there on one of the controllers, either because it's not configured on the controller or because it's not on the trunk, or it's not on the infrastructure uplink, and there's lots of places where we could accidentally miss putting a layer 2 VLAN on there. That means that it's not going to have hitless failover capabilities especially for that specific network, which could be a problem. So if we had a controller outage, everything failed over, and your client was expecting to see that VLAN there, it may not work because if the heartbeat's not working, it's likely that the VLAN's not there. And that would have come up anyway because, like I said, the clients are load balanced to multiple controllers, and all of the clients that are on the other controller, if that VLAN didn't exist, they would be reporting problems anyway. But maybe that's what you're troubleshooting is why do some of my clients work just fine connected to an SSID that's being placed on, say, VLAN 123, but some of my other clients aren't. It seems to be hit or miss. That could be because you're missing one of the VLANs. And this is a really quick way to come to that conclusion as layer 2 connected. So it can actually also tell you which VLANs are missing. Like I said, there's constant heartbeats. They call them probes here. I believe the command here is status. And it shows here which VLANs are failing. And you can see here, I do have a failed VLAN, but I'm layer 2 connected. Why is that? So when I create the cluster, I can actually exclude certain VLANs from having probes run on them because maybe I'm working on positioning that VLAN. This is actually just a construct that we use for wired authentication. So on Aruba switches, we can treat the switches just like we do access points. So when clients connect, they get tunneled to the controllers just like they do if you're connected to a wireless access point. And they use a construct between the controllers and the switches that I just use VLAN 4000. It's not a real VLAN that we're bridging users onto. So I don't want that to be used in my probes. Therefore, it is showing failed. If this was a real VLAN, I would go do whatever I need to do to fix it, get it plumbed correctly in the infrastructure so that the heartbeats do work, and then this would go away. This would go L2 connected, or maybe multiple VLANs have issues. This would then show the next VLAN that you're having problems with, and then you would work on connecting that. We can see that. You would say, I forgot to say, you would see this as layer 3 connected. If one of the VLANs that the probes are configured for aren't working, it'd be layer 2 connected. Otherwise, it's layer 3. And this VLAN's layer 3 because I don't have this plumbed in my infrastructure because it's not a real VLAN. So therefore, it's always going to show layer 3 connected. All right, that is about it. So again, I just wanted to show you a bunch of commands that I use in my day-to-day when I'm doing some troubleshooting. I obviously didn't run through any real-world troubleshooting scenarios, but this at least gives you maybe some more tools in your arsenal to go and help with your troubleshooting efforts. Hopefully I've said something like, oh, I didn't know I was able to see the show data path bridge, and I can see the layer 2 VLANs and what I'm hearing. Hope you got something out of it. And I'll add here, if you're using secure CRT, and I'm not a secure CRT salesman, but a lot of these commands I don't memorize, but put them in the little, there's your show station table that I talked about earlier. There's a show user table. You can see, like, I kind of run through a series of commands here. Maybe I want to look at that VLAN probe. That's a command we just ran just a second ago. Maybe I want to look at my RF neighbors, but the CLI of the controllers is extremely powerful. There are hundreds and thousands of commands that you could run. So again, I hope this highlighted some good commands for at least some basic RF and user troubleshooting. And I will post these commands actually in the comments down below so that you don't have to go hunting through my videos to find them. But anyway, I hope you found it useful. Please leave me a comment down in the chat. Let me know it was useful. Or ask me some other things that you would like to see from really anything Aruba related or RF related, Wi-Fi, I'll specify, or anything in the videos. I'd appreciate it, and I love creating content, so please let me know. All right, everybody have a good day.